Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you're doing well. Welcome to this video and welcome to my channel. In this video we are gonna talk about theoretical and experimental probability. We are going to get familiar with their concept, definition and their differences, and finally we are going to learn how to calculate their value. Okay, without wasting any more time, let's jump into today's lesson. The first topic that we have in this chapter is theoretical probability. What type of probability is called theoretical? The first thing that you need to know about this type of probability is it is 100% based on mathematics. It means we are going to use logic and reasoning for calculating this type of probability. The second thing that you need to know is all outcomes are equally likely. What does it mean all outcomes are equally likely? Assume that we are rolling a die. In that case, getting 1, which is one of the outcome, has the same chance with other outcomes, for example 2, 3, 4, 5, and 6. And the formula that we are going to use for calculating this type of probability is gonna be P, which is probability is equal to number of favorable outcomes divided by number of possible outcomes. Okay, let's solve an example about theoretical probability. Here we have a die and we are gonna roll that die. We want to find the following probabilities. The first one is probability of getting 5. The first thing that we need to do is writing the sample space. What does it mean, sample space? Sample space is a set of all the possible outcomes. When we roll a die, the possible outcomes are going to be 1, 2, 3, 4, 5, and finally 6. Can you please tell me which outcome is favorable? As you can see, I want to find the probability of 5. So only this one is gonna be favorable outcome. So how many favorable outcome do I have? 1, as you can see. And how many possible outcomes do I have? 1, 2, 3, 4, 5, 6. So 1 over 6 is gonna be theoretical probability of 5. P of even, it means when we get even number, it is a favorable outcome. So let's write the sample space again. 1, 2, 3, 4, 5, and finally 6. Can you please tell me which outcomes are favorable? I want to get even number. So 2 is one of them, 4 is one of them, 6 is one of them. What about 8? 8 is an even number. Should I consider that? No, of course not. It's not possible to get 8 when you are rolling a 6-sided die. Okay, how many favorable outcomes do I have in this case? As you can see, I have 3 favorable outcomes. And how many possible outcomes do I have? 1, 2, 3, 4, 5, 6. So 3 over 6 is the answer of this example, and I can simplify that. It's gonna be 1 over 2 or 50%. This is the answer of this example. The second type of probability that we are going to get familiar with is experimental probability. What does it mean? What is the difference between experimental probability and theoretical probability? It is against the theoretical probability. It means it is not 100% based on mathematics. It is based on data which are collected from repeated experiments, trials. So we are going to conduct several experiments, and based on that data, we are going to find the experimental probability. And the formula that we are going to use is going to be P is equal to number of times an event occurs divided by number of times an experiment is done. Okay, let's solve an example about experimental probability. After receiving complaints, a skateboard manufacturer inspected 1,000 skateboards at random. So I'm gonna highlight the number, and I strongly suggest you to do that because it's not gonna hurt you and it's gonna be useful. The manufacturer finds the manufacturer found no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probability as a percent. First, let's find the probability, then we are gonna think about writing that as a percent. P of probability of no defects. Second of all, how can I realize if it is a theoretical probability or experimental probability? Let's check the question with each other again. Is it talking about conducting an experiment or not? Yes, it's talking about conducting an experiment. Look, manufacturer inspected 1000 skateboards at random. So it's gonna be experimental probability. Okay, let's find it. When we talk about no defects, probability of no defects, we must find the number of times that no defects happened. So in 992 skateboard, the manufacturer has found no defects. So I'm going to write it at the top. And what is the total time that experiment has done? As you can see, 1000. So this is going to be, I can write it as 0.992. This is the probability of no defects when you select a skateboard at random. Now we want to write it as a percent. Okay, I have a decimal. I want to write it as percent. What should I do? The only thing that I need to do is multiplying by 100. So 0.992 times 100 is gonna be 99.2, and do not forget the percentage symbol. This is the answer of this example. Find the theoretical probability of landing on given sections of a spinner. As you can see, we have a spinner and it has a hand. This hand is gonna stop on one of the sections. First of all, yes, the question says it is theoretical probability, but if it didn't say, how could I realize that this is talking about theoretical probability? Is it talking about conducting an experiment? No, of course not. So we are going to use mathematic logic reasoning and we can realize it's talking about theoretical probability. The first probability that we had is P of purple. So let's write the sample space with each other. I'm going to write the sample space based on color because the probability is talking about color. As you can see, I have 2 purple. I'm going to write it with P, 1P, 2P. I have 2 yellows. I'm going to show it with Y, lowercase of y. 3 blues. So 3. This time I'm going to write with capital. And finally, I have 1 red. This is the sample space that I have here. I want to find the probability of purple. How many favorable outcomes do I have? 1, 2. So 2 is going to be at the top. And how many possible outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8. 2 over 8. Can I simplify that? Yes, of course. And the answer is going to be 1 over 4 or 25% if you multiply it by 100. The second probability that I'm going to calculate is P of even. So this time I must write the sample space based on numbers because it's talking about numbers. So S is going to be, what are the numbers? It's going to be from 1 to 8. 1, 2, 3, 4, 5, 6, 7, and finally 8. What are the favorable outcomes? 2, which is an even number, 4, even number, 6, even number, 8, even number. How many favorable outcomes do I have? 4. I'm sorry, let me write it here. How many favorable outcomes do I have? 4. How many possible outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be 1 over 2 or 50%. red. What do I have? I have 2 purples, P, 2 yellows, Y, 3 blues, B, and 1 red. Which one is favorable outcome when we got red? So how many favorable outcomes do I have? 1. And how many possible outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be 1/8. This is the probability of getting red. Again, here we want to find the probability of getting 1 or 6. Let's write the sample space again. For the numbers, it's gonna be 1, 2, 8. How many favorable outcomes do I have? If I get 1 or 8, this is gonna be the desired outcome. So I have 2 favorable outcomes. The number of total possible outcomes is gonna be 8. If I simplify that, it's gonna be 1/4. White. Let's write the sample space based on the colors. Purple, purple, yellow, yellow, blue, 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 and red. I want to find the probability of getting white. Can you see any white color here? No, of course, in the sample space, we cannot find any white color. So what is the number of favorable outcomes? It's gonna be 0. And how many possible outcomes do we have? 8. It's gonna be 0. It means it is completely impossible. And not blue. Okay, I'm gonna use the sample space that I wrote for the previous part. If it is not blue, how many favorable outcomes do we have? I'm gonna draw a square around it. It is favorable outcome. It's favorable outcome. These 3 are blue and we have nothing to do with them. And finally this one. Okay, how many favorable outcomes do we have? 5. And how many possible outcomes do we have? 8. And this is the answer of this example. Here we have another example. A forest contains about 500 trees. I told you highlight this number. You randomly pick 67 trees and find that 27 of them are oaks. So I'm gonna highlight those numbers. What is the experimental probability that a tree in the forest is an oak? So I'm gonna write P. I'm gonna find the P of what? Oak. And second of all, is it talking about experimental probability or theoretical probability? First of all, the question is saying find the experimental probability. And second of all, if the question didn't say, we could easily realize that it was experimental probability. Because we conduct an experiment, we randomly tick some of the trees, okay? So, how many times did we find oak in the forest? As you can see, 27 of the trees are oaks. 27 is gonna be in the numerator. What is the number? How many trees did we pick in total? As you can see, this is the number of times that experiment has conducted, over 67. And this is the answer of this example. What about 500? Should we do anything with that? No, we have nothing to do with 500 trees because 27 is the number of times that we find oak trees in the forest, and 67 is the number of times that we conduct the experiment, and these are the only 2 numbers that we need. And this is the answer of this example. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.